I call this data science and public administration. This is just my research, right? This is just what I do. So, but thanks for inviting me to talk, and thanks to everybody who's already talked. Those really fascinating presentations, and I'm glad ITVest organized this. So I'll just introduce myself to start. So I'm an associate professor in political science in the public administration section. My research is on political accountability, how politicians sort of control bureaucracy and use that as a way to short circuit democratic accountability sometimes. I also study why political leaders talk about the things they do, which political issues find their way onto the agenda. And then there's a part of my work that's on kind of digital and computational methods. But I'd say my work, so in contrast to the other folks who've talked, is just really empirical and applied in that way. So the way I'd kind of describe the way my digital workflow ends up looking is, I tell my students all the time that to be skeptical of the term big data, but I think here it helps illustrate kind of what I'm up to. I end up building a lot of data sets from, for example, many local government websites or government databases, media outlets, international organizations, regulators, so on. Often things that we just don't have in political science a sort of canned data resource on that people can go to, but instead you have to build that stuff if you want to study it. And I find myself using a lot of applied machine learning, primarily to measure concepts. So things like, we need to label some text. Is this about education policy, or is it about energy policy? And then there are times when I'm using machine learning algorithms that are more focused on identifying patterns. So, where is there some signal in the noise here? Can we sort of validate that as a measurement of something we care about, and so on. And then I'm all of my work is essentially moving to statistical models to test hypotheses after that. And I also teach a lot in this area. So this was kind of, as I was talking to Bettina before I set up this presentation, she gave me some suggestions about really focusing on kind of my experience teaching and using this stuff, and kind of how that might be useful for folks who are considering doing that. So I teach what we call our sort of political data science course at the Aarhus Department of Political Science. And I guess it's the sexy title, but we got a lot of students who show up for it every year. And I actually really liked Anna's presentation and what he said about using, what I end up calling data science skills in qualitative research, because we've set up the course precisely to reflect that. So we have one course where students learn automated data collection, visualization, data management, applied machine learning, and so on. And that course, we invite folks who don't have any quantitative research interest to take it, because computational skills can still be so valuable to the research designs that are interested in doing. And then we offer an observational statistics course alongside that draws on that material. So those folks, we ask them to take both classes. So it's kind of a 20 ECTS versus 10 thing. Anyway, so this is kind of the perspective I'll come at most of what I have to say. And I guess it's worth just sort of noting here that if you're really doing a lot of sort of just empirical work, data-driven empirical work like I'm doing, and then you'll find that like data collection, sort of digitizing your process of data collection and automating that process is a real sort of part of that, especially in my case where I'm interacting with the public sector. So much of that is online, right? My favorite example of this is in 2011, the Obama administration actually launched a campaign to cut waste by reducing the number of websites that the government ran. It's a bit like in the 1970s, the United States passed a law, the Paper Reduction Act, to quit cutting down so many trees. And here we are in the digital age going, oh, the energy resources and the manpower it takes to maintain all these websites is too much. So this has just become like a part of what I have to do. So I think the sort of upshot of the way that digitalization has made everything happen online is that there are a lot of advantages to moving in a sort of digital computational direction with things that might be a part of your workflow already, right? Getting those skills can help you move a lot faster, of course, eventually, because there's a hurdle to get over there. But you can also be quite a bit more thorough with it. So when you set a rule or you write some code, that computer's not going to get tired, right? It'll just sort of do it. And depending on the workflow you use, you can actually really integrate that into the rest of what you do. So in my case, this is a little bit easier because if I'm doing statistical analyses, well, that, when I collect data automatically or use some machine learning algorithm, that format is going to feed right into a statistical analysis. However, even for folks who use qualitative research, a lot of the tools, like, for example, in vivo, that you would use as a part of your workflow, you can sort of integrate data right into that quite easily. And depending on the software you use, it can be quite a low budget solution. I think the logic is really compelling for academic researchers, though, because there are a number of trends that I'm sure we're all aware of that make it kind of like attractive to be able to do more work digitally and computationally. I mean, budgets are getting smaller for big data collection projects. That's just hard to motivate. It's hard to get the kind of budget you need to get an army of undergraduates to collect data for you. Information sort of is growing a lot, obviously, because of the internet, but furthermore, that information decays really fast. It disappears so quickly. And so you have to be able to get it when it's available, if you want to have it at all sometimes. And then furthermore, and this is something perhaps I just see in my field, but I would imagine it's more widespread, and that is that expectations keep growing, right? So the question you'll get from reviewers sometimes is, why did you just take a sample? Why didn't you just get all of it, right? And that's sometimes a challenging one to answer. So part of how I ended up doing this, though, was, I think, a really problem-driven way. So my background before I got into academia was as an anti-corruption activist. I worked for several years at Transparency International Romania. And after doing that, I had gotten a master's degree in political science from the University of Bucharest, and I was hoping to just sort of work in activism, but I was frustrated endlessly at why we sort of couldn't succeed at the things we were trying to do. And so when I started in graduate school in political science in 2009, comparative politics, the field I was in, was quite light on data. Laws got all the attention, and there was not a lot of attention devoted to executive orders and decrees and things like that, where the sort of, you might think the action really happens in actually implementing laws. And so the sort of burden was on me to collect that data if I wanted to have it. So that kind of leads me to some examples of the way that I've used these types of skills in my work. So, for example, I have some research where I've shown that politicians delegate to bureaucracy sometimes to avoid blame for policy outcomes that won't be popular, right? In the example I was looking at, I was showing that political corruption plus cases where politicians can exercise informal influence over bureaucracy results in more delegation. And the way I did that was with a lot of data that I collected from the European Union. So I had to collect data on hundreds of commission directives and thousands of transposition reports, and then sort of process all of that, label it appropriately, so on. Then I was, able to sort of show those trends in a big data set like that. More recently, I've worked on the political agenda in Danish municipalities. So we're finishing up a book project this year in which we're sort of explaining, here's how things get on the agenda in Danish kommune. What is how does issue focus sort of move from one thing to another? And to do that, the sort of computational methods were a huge part of our workflow, right? Not only, we sort of had to automate good parts of the data collection because there are 98 municipalities and we were collecting a good bit of data. But then furthermore, that left us with almost 300,000 agenda items over that period. And we needed to label the policy area of all of them. And so we ended up, using machine learning to actually sort of apply those labels, right? So we had human coders read some of them and then apply labels, and then we would use the algorithm to then forecast labels for the rest of the data set. And that was, maybe a year-long process of getting that to an acceptable accuracy level. But in the end, we can say a lot about, first of all, how big is the agenda in different municipalities, but then how diverse is the agenda? How complex is that agenda? And I can tell you that turns out, around almost 20% of the agenda in the average municipality in Denmark is normally about housing. Environment, local economy are up there, but you can see these things primarily because, or precisely because, we had the tools to actually go ahead and put this together. So my path to get here, and Bettina suggested I talk about a few of these things that I want to mention next. So my path to get here was I entered graduate school with zero tech skills. I didn't have that background at all. But I began with sort of collecting data at scale because, well, that was my real motivation. But I found very quickly that I needed to integrate computational methods into what I was doing because we collect a lot of data and you very swiftly are in a world where you can't handle it by hand, right? You can't do the normal tools that, at least in political science, were the way you would do things. Read the text and then say, well, this is this and this is that. And that's not really feasible, right? And so I found myself learning a lot of applied machine learning methods to help me label data and do things like that. And so I just have like a few things that, sort of my subjective perspective on doing applied empirical work, like, what is a good frame of mind to be in when you're thinking to yourself, okay, how do I integrate more computational work into what I'm doing? And I think the first thing that I've sort of found as a good guiding principle is to be really ruthlessly problem driven. Because I'm in academia, I'm a curious person, but I really try to restrain myself from just running off and learning something just because I think, oh, I might use this. But instead, okay, what's my problem? How do I solve this? I learn new skills so I can do something, and I use the problems I have to get that new skill, right? And second, so learning to code was a new skill for me. And I found that a good way to sort of think about scripting languages, which is all that I ever use, is to really think of them as languages, and I mean that in a certain way. Like, it doesn't really make sense to just say, oh, I'm going to just study Chinese, like just because, right? There are people out there who do that. Linguists perhaps are into that sort of thing, but the majority of people say, well, I'm going to learn Chinese so I can talk to Chinese people or read something that's in Chinese. And that's, I think, a really useful way to think about programming as well. It's fine to just say, well, okay, all the cool kids are using this language, but I can do what I need with the skills I have in, say, for example, I use R. And I've felt so many times that perhaps I should branch out into Python because there's so many neat things you could do there. But I inevitably find that I can do what I need to do in R. And so I should just sort of execute what I have to do. And I've always been looking for that problem that's going to drive me to learn the next language, and I haven't gotten there yet. But I think that's a useful model when thinking about languages, because they really are just a means to an end. They're a medium for doing something. I do think it is useful, having said that, to have some background, and this is the kind of thing where it helps to take some sort of a short course or something to get some basic principles for coding, because once this becomes the way that you're doing your work, there is sort of a wealth of knowledge out there about how to organize your workflow in an effective way that is not obvious if you're not from a background where you have a lot of experience writing code. Just from simple things to, from commenting your code, version numbering, but things that are actually really useful that seem complicated, like Git, are very much worth your time. And Bettina also just suggested I asked about what I would do differently. I think if I had followed my own advice from the start, I would have been happier. But I think also, because I was really looking to collect really big data sets and take on really big projects, I was often, tempted to start there. And I think I've come to a different mindset where taking smaller bites, doing the pilot project, and then building up to the really big thing that I'm planning to do has become my workflow. So thanks again, and I've put my email in the slides, so please feel free to get in touch if I can be a resource for anything.